The objective for today is to evaluate trig ratios from a given right triangle. In order to do that, the first thing we're going to do is understand these terms, which are called as the reference angle, the hypotenuse, opposite side, and the adjacent side. As we saw earlier, the reference angle could be one of the angles that is being used in a problem. So this is the right triangle, therefore the angle over here is 90 degrees. And the reference angle could either be C or A, depending on what the problem is asking. So reference angle, say C is the reference angle, the angle which is being used in the particular problem. So with respect to the reference angle, we are going to identify what are the opposite side, adjacent side, and hypotenuse. So in the triangle ABC, let's call the reference angle to be C. The hypotenuse for in this triangle ABC is AC. The opposite side is the side which is across from C, which is going to be AB. And the adjacent side is the side that contains the angle, which contains the reference angle, which is going to be BC. So these are the three main lengths that we are going to use to find the trig ratios. So the first one, so it's important to understand the hypotenuse, which is very simple because it is right across from 90 degrees. So that's the hypotenuse, the longest side in a right triangle. The opposite side is AB and the adjacent side is BC. And so once we know the three sides, we are ready to go look at the six trig ratios. As we've seen earlier, the six trig ratios are with respect to the right triangle. See, let's call this as triangle A, B, and C. And the SOHCAHTOA is an easy way to remember the trig ratios. So sine, let's say angle C is the reference angle. So sine of angle C and cosine of angle C, tan, then cosecant, secant, and cos. So we'll get to that part. But the first thing that we do, first step is, in given any triangle, you're going to identify the adjacent. So the first one is identify the hypotenuse, the opposite side, and the adjacent side with respect to the reference angle. So if C is the reference angle, we have the hypotenuse to be AC, the opposite side is AB, and the adjacent side is BC. So that's the first thing that we're going to do. Whenever you see a right triangle, you sort of try to identify what are the hypotenuse, opposite, and the adjacent side. So, as this suggests, sine C is going to be, so O stands for the opposite. So sine is opposite over hypotenuse. So I have opposite, sine is going to be opposite over hypotenuse. And since you know what sine is, cosecant is just going to be the reciprocal of it. So cosecant C will be hypotenuse over the opposite side. So sine, as it goes by this name, your sine is going to be opposite over hypotenuse. And therefore the cosecant will be, you just flip this and you get hypotenuse over opposite. Then cosine is here. This is sine, this is cosine, will be adjacent over hypotenuse. So adjacent over hypotenuse. Now secant is going to be, when you flip the cosecant or the cosine, you get the secant, which is hypotenuse over opposite. And the last one, which is tan C, will be opposite. The tan will be opposite over adjacent. So opposite over adjacent. And the cot, which is nothing but the cotangent, will be adjacent over opposite. So these are the 6 trig ratios that you'll be using. How do I identify it? So once you know this, you'll be able to figure it out. So now, as an example, we'll take a triangle and we'll try to establish the trig ratios for all the 3 sides for the triangle. So let's take a right triangle. Let's have a right triangle. So the right triangle so A, B, and C, and let's take the reference angle to be A, and we will write the 6 trig ratios. And you take the basic right triangle, which has measurements 3, 4, and 5. So here all the 3 sides are given. And now, before we get started with establishing the trig ratios, we can do, so A is the reference angle. We'll identify the hypotenuse, adjacent, and opposite. So step 1 is that hypotenuse of this triangle, and that one is the right, and opposite side is over here, and the adjacent side is over here. So first step is to identify the hypotenuse, adjacent, and opposite, or present there. Now apply the trig identities. So sine A will be opposite over hypotenuse. The sine is going to be opposite side over the hypotenuse. So since I have the sine, the cosecant will be 5 over 4. And cosine A is 3 over 5. So therefore secant A will be 5 over 3. And tan A is 4 over 3, and cot A is 3 over 4. So these are the 6 trig ratios. So once you know this, and this problem is simple because you are given the 3 sides already. So the 3 sides being 3, 4, and 5. And once you know that, you're using a subtotal. So opposite over hypotenuse, that is sine. Cosine is adjacent over hypotenuse, and tan is opposite over adjacent. So once you know this, you can easily establish what cosecant, secant, and cot are. And now for the next example is where I am not given one of the sides, where I do not know the third side. So we use Pythagoras theorem for that. So the next example is where we are finding the third side. So say you're given a triangle A, B, and C. This is given to be the 8, and this is 4. So we need to find, and we're asked to find the 6 trig ratios. So in order to find the 6 trig ratios, the first step is to find the missing sign. So in order to find the missing side, what you do is you apply the Pythagoras theorem, which says this is A, B, and C. So A squared plus B squared equals C squared. And you do A squared plus 4 squared equals 8 squared. So A squared plus 16, 64. And then you have to subtract both sides by 16. So A squared equals 64 minus 16, which gives you 48. So A is square root of 48. So after this point, all that is left is to simplify the square root of 48. So square root of 48 can be simplified further, and then we establish the trig ratios for for this triangle ABC. So square root of 48 would be, you can write this as 2 times 24, 3 times 16, and now this is going to be the way we split it. So this is 4 square root of 50. The square root of 48 can also be written as 4 square root of 3, and all that is left is to apply SOHCAHTOA to get the 6 trig ratios. So I'm rewriting square root of 48 as 4 times square root of